Good morning, Tehmina Khan is here in TKMaths A Level. In today's video, which is video number 2 on chapter or lesson 6, equilibrium and acceleration under concurrent forces. In the first video, you can see 6.1 here. We discussed and understood what is particle in equilibrium under more than 3 forces. Now we are talking about motion of a particle on the plane, right? Like it is this one. So let's see here. First of all, we will have a little recap on the previous concept because this concept is built upon it. So I have taken here 2 diagrams. Each of the diagram given below shows a particle in equilibrium under the forces shown in the diagram. So I have taken rather one example. So you can see there are 3 forces, P Newton, Q Newton and 10 Newton. And imagine this is your particle in the center. Now the requirement is that you have to obtain an equation when you will resolve it in the direction of OX, and then obtain an equation by resolving in the direction OY, and then using those equations you have to find the unknown forces. So unknown forces are PQ, P and Q. So I have solved this question and I will discuss it one by one. First of all, we have to resolve these forces along OX and along OY. So I will show you in the diagram here, but this P force, if I resolve it, it will be like this, right? This will be your P sine 30. This is P cos 30. Similarly, if you resolve Q along OX and along OY, this one will be your Q sine 60. This one will be Q cos 60. Similarly, if you resolve this one, 10 Newton, then this is your 10 sine 60 and this is 10 cos 60. So I've done here neatly because I'm going to use this in the solving the unknown forces. So first of all, let's resolve along x-axis. So I can see this is one force here. Along x-axis, Q cos 60 is in the direction. And similarly, 10 cos 60 is also in this direction. So, because P cos 30 is on the right hand side, but Q and 10 is on the left hand side, so that's why you will make an equation like this. It is equilibrium, so balancing both the forces. Then simply solve it and get the equation. After that, I will resolve it along OY, in the direction of OY. So if I see Q, this one is acting upward, Q sine 60. This is acting upward, P sine 30. But 10 sine 60 is acting downward and 8 is also acting downward. So this is how we have formed an equation. Upward forces on the one side and downward forces on the other side. Because it is in equilibrium, they will balance each other. So let me call this equation 2. Now we will solve equation 1 and 2 together, whatever method you want to solve. So I have taken the value of P from here and substituted here and then simplified it. So this is how you will get the value of P and Q. So this was last time concept. So now let's focus on the motion of a particle on a plane. Now when we are talking about that forces are acting on a particle and it is in motion, an object is accelerating, we have to use Newton's second law of motion, which is F is equals to ma. How we will use it, let's see. Just a minute. Okay. Now the question is, and diagram is here, then I will solve in front of you. Each of the diagram, I have taken here 2 diagrams to explain this concept. Given below shows a body of mass 10 kg. Okay. So you can see here, this is the body which is acting downward, vertically downward, 10 kg. Obtain an equation by resolving forces perpendicular to the direction of motion. Now this is your plane, right? Whenever you are resolving forces on the plane, it's better to resolve perpendicular to the plane and parallel to the plane, rather than taking horizontally and vertically. This is the best option to solve them properly. Okay, so now let's resolve it first and then we will solve it. Okay, so this 10 kg, which will be 100 Newton, if I resolve it, it will come from here and then from here, right? So this will be your what? This angle will be 30 degree. This is acting downward force. It will be resolving perpendicular to the plane. It will be 100 because 10 kg mean 100 Newton, right? So it could be 10g cos 30 and this one will be 10g sin 30. So I have resolved these forces and now I have to find out what? Unknown force, which is R in this case. So let me resolve it along R perpendicular to the plane. I can say R is equals to 10g cos 30. R is acting upward, 10g cos 30 downward. There is no motion happening perpendicular to the plane, so I am equating them. So R is equals to, use the calculator, you will get it. I am writing in 3 significant figure, 86.6 Newton. Now I have to resolve it parallel to the plane. Now this is telling you acceleration is happening downward. It means this force is downward, but there is no force upward, right? So if I see F is equals to ma, resultant force is downward, which is 10g sin 30. There is no upward force, so we can't say anything minus 0 because no upward force. If there was upward force, I would have written here is equals to 10a. And then you can solve it. You will get 5 meter per second square. Let's see this question now, right? In this case, acceleration is happening upward. Maybe the force P is definitely is bigger than the other force. Which is the other force? Due to the weight in this case. So if I resolve it, this weight, which is again 10 kg, so perpendicular to the plane and parallel to the plane. Okay, so this angle will be 30 and this one will be 10 cos 30 and this one will be 10 sin 30. So again, as no motion is happening perpendicular to the plane, so I can say R is equals to 10g, sorry I have written 10, it should be 10g because 10 kg, so 10g is a Newton, 10g cos 30, right? So R is equals to 86.6 Newton. Now parallel to the plane, the acceleration is happening. So the force acting upward is more than the force acting downward. So upward force is P. Okay, by the way, let me write here Newton's second law of motion first. F is equals to ma. This is my resultant force. So P minus downward force is 10g sin 30 is equals to ma. So P is equals to, now you know your A acceleration is 2. So it is 20 minus 100 sin 30. Achha, by the way, I have taken G as 10 meter per second square because this is what is taken in M1. You will not take 9.8, which is usually taken in physics, right? So P is 70 Newton. So now it is a time for your checking your understanding. So solve this question, then I will show you the solution of this. Now this time acceleration is happening downward. So you can put the video on pause and solve it. So I am just explaining. If you have solved, then you can check your working. You will resolve this force perpendicular to the plane and parallel to the plane. This will be theta because this angle is theta. This is 10g cos theta This is tan g sine theta. Now perpendicular to the plane there is no motion happening. So you can say 49 is equals to tan g cos theta. So you get the value of theta from here, right? And now parallel to the plane, because acceleration is happening downward, so this force which is due to the weight is more than the force which is acting upward. So that's why I will say tan g sine theta minus 50 in Newton's second law of motion. So tan g sine theta minus 50 is equals to tan a. Substitute the value of theta and I got the answer. So I hope you understood this, and in the next video we will see system involving more than one particle. So what do I mean? These type of questions. So connection will be, link will be given in the description below. Thank you very much for watching the video. Please press subscribe and like button and share it with your friends. Take care. Allah Hafiz.